Hi everyone, again we are talking a little bit about reciprocal quotient and Pythagorean identities. So a little bit of review. My reciprocal identities are as shown, and anything times its reciprocal will be 1. So sine times cosecant, cosecant times secant, tangent times cotangent, they'll all be 1. Now for my Pythagorean identities, I start with sine squared of x plus cosine squared of x equals 1. And the idea is if I take everything and I divide by, say, sine squared of x, then I will end up with 1 plus cosine over sine is cotangent, and 1 over sine is cosecant. Okay? Now, conversely, if I take everything and I divide by cosine squared of x, then instead I'll end up with sine over cosine, which is tangent. Cosine over cosine is 1, and then 1 over cosine is secant squared of x. Okay, so that's how I get the other Pythagorean identities. Okay, now let's go through just a few examples. So first they're asking me to transform 1 plus cosine times 1 minus cosine to sine squared. So right off the bat I know I'm going to use my trigonometric identity, my Pythagorean identity, excuse me, because I have sine squared here, and I know that when I multiply my cosines, I'll end up with cosine squared. So they are asking me to prove that 1 plus cosine of a times 1 minus cosine of a is equal to sine squared of a. So again, I'm going to box this. I'm going to write that this is my goal, and I'm going to manipulate only the left-hand side. So when I multiply this out, I'll end up with 1 minus cosine squared of a. And again, from my Pythagorean identity, I know that sine squared plus cosine squared equals 1. So if I move my cosine squared over and I solve for sine squared, it'll just be 1 minus cosine. So I can make this direct substitution, and I see that sine squared of a is equal to sine squared of a, so I have reached my goal and I have completed my proof. Okay, next they're asking me to transform secant over sine minus sine over cosine to cotangent. Okay, so kind of two methods that we're going to talk about here. One method, again, is to rewrite everything in terms of sine and cosine. So if I go ahead and do that, I'll end up with 1 over cosine over sine of x minus sine over cosine. And this should be equal to cotangent, which again is my goal. Okay, when I work with my complex fraction here, again, I know that dividing by a fraction is the same thing as multiplying by its reciprocal. So if I multiply by my reciprocal, I'll end up with 1 over sine times cosine minus sine of x over cosine of x. Okay, from here, when I'm working with fractions, and especially if I'm working with trig, my goal will be to get a common denominator. Okay, that's another one of my strategies when I'm doing proofs, is to get a common denominator. So in this case, my common denominator will be sine times cosine. So I'm going to multiply my right fraction by sine over sine to get a common denominator. This leaves me with 1 over sine times cosine minus sine squared over sine times cosine. And now I can combine my fractions. So I end up with 1 minus sine squared of x over sine of x times cosine of x. This right here, again, I can use my Pythagorean identity and straight substitute cosine squared of x in for 1 minus sine squared of x. And nothing has happened to my denominator. Okay, so I see that something can cancel. I'll end up with just cosine of x divided by sine of x, which is equal to cotangent. Okay, so I have reached my goal. I am done with my proof. Okay, Your homework again is listed below, so if you have any questions, let me know, and have a fantastic rest of your day.